Okay, this is section 4.5, composing reflections over intersecting lines. If you haven't done so already, make sure you pause the video and read section 4.5 before continuing on. So in section 4.4 we looked at translations, and we defined translations as being two reflections over parallel lines. Now, instead of the lines being parallel, we're going to look at, well, what happens when we have lines that are intersecting each other. And when that happens, we get a rotation when we do those two reflections. Okay? So like translations, we can define a rotation in terms of a composite of reflections, and therefore all properties are preserved that are preserved under reflections are also preserved under rotations. Okay? Well, to define a rotation, we're going to say it's the composite of two reflections over intersecting lines. So in translations, it was two reflections over parallel lines. For rotations, it's two reflections over intersecting lines. Okay? That is, when line J intersects line K, the composite of reflections over J and K is a rotation about the intersection of J and K. Okay? So the center of the rotation, same as the rotations that we were doing back in chapter 3. That center of rotation is the intersection of those two lines. Okay? Now, describing specific rotations. To describe a rotation, first of all, we need a magnitude of a rotation. And when we talk about the magnitude, it's got to be represented by the measure of the term. Okay, so whatever the turn is, the number of degrees of the turn, that's the magnitude of the rotation. Okay, this can be found by measuring the angle formed between any point in the preimage, the center, and the image point of the preimage point. Okay, we'll look at doing that here in just a little bit. Okay, the center of rotation is the intersection of the two lines, as we mentioned. And then finally, we need a direction of rotation. The direction is either going to be a clockwise, which has a negative magnitude, or counterclockwise, which would have a positive magnitude. So there's three things that we need then to define a rotation. We need a magnitude for that rotation, we need a center for that rotation, and then we need a direction for that rotation. Okay, let's take a look at example 1 here. Then it says, describe the rotation that maps figure EFGH onto figure E prime, F prime, G prime, and H prime. Well, to describe a rotation, as I mentioned just earlier, we need three things. We need to know what is the magnitude of the rotation, what is the center of the rotation, and what is the direction of that rotation. Now, usually I'm going to combine the magnitude and the direction together by making it positive if it's counterclockwise and negative if it's clockwise. Okay? So let's take a look at what we have here. So if I look at this figure, EFGH, that's my preimage. Okay? So you might want to get that down, E prime, F prime, G prime, H prime, which is my image. So that means that the direction that I'm going is this direction. Okay? Therefore, my direction is going to be negative. The magnitude of that rotation is given by this angle, HTH prime. So that represents the magnitude. And the center is that point that we're rotating it about, which in this case is point T. Okay? So my answer to that problem would be a magnitude of a negative 125 degrees. Remember, that represents a direction and a value of the rotation in terms of degrees. And then the center would be T. Alright, next I'd like to take a look at rotations on about the origin on a coordinate grid. And the ones that we're most interested in and the ones that you'll be responsible for are multiples of 90 degrees. Okay? So if I'm going to take a point, any point in general, and rotate it about the origin, a multiple of 90 degrees, we can come up with some pretty good rules to kind of help us do that. But to get to where those rules are, I want to just demonstrate using this particular point on this grid. So I have the point right now 2, 1. And if I do each one of those rotations to it, let's see where it goes. Well, you can take your coordinate grid and rotate it. So if I rotate this 90 degrees, we can now see where the new point is. So you'll notice that my new point is at negative 1, 2. Okay? So if 2, 1 goes to negative 1, 2, really what's happened is I have my point AB goes to the point negative B, A. And now I want to do a rotation of 180 degrees. So I'm going to take this thing, and I'm going to turn it 180 degrees, and here's my new point, which would be the point negative 2, negative 1. So I take my original values, and both of them became negative. Therefore, AB goes to negative A, negative B. So basically, we just need to switch the signs on both the x and the y coordinate. And then I want to do a rotation of 270 degrees. Well, if I do a rotation of 270 degrees, so the point 2, 1 went to the point 1, negative 2. Therefore, AB goes to B, negative A in general. Okay? And then finally, if I'm going to do a rotation of 360 degrees, well, 360 degrees is all the way around in a full circle. Therefore, that point is going to end up right back where it started. So the rotation of 360 degrees of AB is itself AB. Okay? So that's a general rule that you can use to kind of do rotations of multiples of 90 degrees around the origin. And you can spin your own graph if you don't remember the general rules.